David. So I think Thierry's still actually talking about Atomic.js. Has he stopped yet? Is he here? No, he is. Only just finished. Thanks, David, for inviting me to this. First of, was it once a quarter? I really like the logo. We need a description about what that's all about. It looks like it's from 1997, when Yahoo was popular. Only joking, only joking. That's as funny as I get, honestly. Sorry. Okay. Hi, my name's Phil Leggetter. This talk is on building front-end web apps at scale, hopefully relevant to everyone here. I actually work for a company called Pusher. Who's heard of Pusher? Okay, not bad. More people have now. I've got a silly job title. We're a group of around 20 people. There's about 3 on the growth team, although we all do a bit of evangelism from now and again. So it's about adding real-time functionality to web and mobile applications, really focusing on integration with existing technology stacks. But this talk isn't about that. It's about FEDLondon.js. So I used to work at a company called Kaplan Systems. I've worked there a bunch of times. I actually joined as a graduate in 2001. And they open sourced a toolkit about a year and a half ago, which helped multiple teams in large companies build large, complex JavaScript applications. And this was meant to be the description of this talk, but I think I put workflows in about 4 times. So it's really about the concepts and practices that fed into the workflows and application architecture that was core to FEDLondon.js toolkit. So the interesting thing about the toolkit is that it's about tooling. It's about compiling your JavaScript, not too much, so it's still readable. But it also has a thin layer of application architecture, and the tooling knows about that application architecture, which actually offers a level of power. Hopefully I'll kind of talk about that. I'm not going to talk specifically about FEDLondon.js. I think a lot of this stuff you can apply elsewhere. So to give you a bit of a background, this is something that Kaplan Systems do. So they offer a whole suite of technologies for integrating into back-end systems and building web trading platforms. So this is the architecture diagram that's on the Kaplan website. Part of this was building JavaScript-based, now HTML5 apps, and we did that in 2001. So we were building complex JavaScript apps back then, targeting only IE, not Netscape Navigator. But obviously in the past 4 years, this application has got quite complex, and I'll kind of show it. And we got to a point where the code we were writing, managing this really large-scale JavaScript app, was a complete pain. So we had to reverse engineer kind of the problems we were seeing, and we tried to create some tooling and processes to make sure that we didn't come across those problems again, to actually improve our developer experience, to make sure that we're building these complex web apps at scale. So I'll try and define what they are to give you a bit of background. So if you think about building a complex, highly functional application, the more functionality you have, the more code you're going to have. It makes sense. Atomic CSS looks like a good way of making sure that you keep that to a minimum. So there are ways of making sure you keep code to a minimum, reuse code and so on, but it doesn't matter how good you are, you're going to create more code. So as an example, Kaplan Trader isn't actually an SDK that we build apps on top of. Kaplan built apps on top of. It's 1,000 lines of JavaScript, 131,000 lines of code, 95,000 lines of test code. I took these stats about a year ago, actually, so it may have increased or decreased from then. And then apps that are built on top of that SDK are 50,000 lines of code and 21,000 lines of test code. Now, some people might be thinking we haven't got enough tests. That's probably fair enough. But it's quite a lot of code, quite a lot of tests. And that's just JavaScript. So on top of that, there's HTML templates, there's CSS, there's images, there's ITN, there's config, any other asset you can think of in a front-end application. So that's pretty big. Has anyone got an app that they work on as big as that? Cool. So yeah, there definitely are apps that big. I think Kaplan are one of the companies that do have that. These apps are going to be complex. I'm going to kind of provide Gmail as a reference point. Who uses Gmail? Most people. Okay, so we all kind of accept it's the go-to single-page application. And it does offer quite a lot of complex functionality, from searching your emails, paging through them, filtering them, going through categories, jumping into your contacts, composing in this compose pop-up a rich email, searching contacts from there, adding rich content, adding attachments from Google Drive and so on. So it offers a lot of stuff. This is not a particularly nice looking application, but this is Kaplan Trader 2 from about 2 years ago. They're on Kaplan Trader 4 now. And again, the point of this little video is just to really demonstrate it's a complex front-end application that lets people execute trades and view real-time data. So I'm kind of switching between layouts here. There's graphing, there's real-time news, there's grids. They can be really big grids. Don't know what that is, got to be honest, some sort of financial thing. Behind this, there's a lot of data, so tens of thousands of rows of data that as you scroll, it's fetching new data and so on. Drag and drop stuff. So you get the idea. There's layout management, there's complex individual kind of components, lots of stuff going on there. The reason I chose this example is because it was a demo that we just threw anything we could into. So apps might not be quite that complex in reality, but there might be an FX one, an FI one, a sales-focused one, and so on. So both these apps kind of share similar things in that they're a single-page app. They offer complex functionality. You know, there's quite an interesting thing in terms of complex interaction. So the user can do relatively complex things with them to achieve a number of goals. You know, I want to do this, execute a trade. I want to send an email. The components within the front end, the JavaScript, those things communicating with each other. There's a lot of complex interactions that can go on there. And there's also a lot of complex client-server interactions or potentially peer-to-peer interactions if you're using WebRTC. So there's all these complex interactions going on within the app. And I would say leave open all day. Certainly the trading applications they do, certainly Gmail you do. But I think really the things I'm going to talk about will hopefully be applicable to anything that's has a rich kind of UI. The app's going to be around for a long time. And because of that, features will change. You know, you add new features to an application. Existing ones will evolve. Ones that aren't used from a business point of view, you notice that and you remove them. And the point there really is that your application architecture, the way that you write these apps, needs to support that change. So I remember going to an interview at Lloyd's TSB ages ago, and they actually called their development department change management. So that's kind of, if you think about large complex applications, a lot of the time it's how do you make sure that you can support change. And that's the same in these apps. This is just an example of feature progression in Gmail from something focusing on just chat, going through to Hangouts and almost asking users to jump on a video call. This code base is going to be around for a long time. You could potentially lock one person up in an office and just get them to code on it. But the likelihood is you're going to have multiple people contribute to that over time. People might change projects, people might leave the company, new people will come in. So you need to support that sort of thing. You can have different types of people that contribute to that code base. So from front-end devs to maybe back-end devs, maybe providing schemas to APIs that you're interacting with, designers providing assets or updating CSS or modifying JavaScript behaviors, QA who should at least be reviewing tests. You know, at Kaplan we have at least one QA on each team, but then they also write tests around the functionality that you've written, and so on. Content, anything. So I think that kind of introduces a whole bunch of problems. So how do you structure that large code base? I'm pretty sure that people here will have an idea of how you do that, but it is a problem that needs to be solved. How do you support those complex interactions between these components that can come and go? How do you make sure that everyone can work in harmony without making code changes that break someone else's piece of functionality? How do you support that change in both features within the app, but also in terms of the technology that you're using? We know how fast the web's moving forward. So how do you make sure that you can use the right piece of functionality, the right library for your application now, but then you can change to use something that uses native web technologies in the browser in the future? And how do you make sure that all your developers are focusing on building business functionality rather than managing maintenance problems or writing the next grunt task? And above all of this, one of the things that we really fed into this was that people are executing trades in these applications, so they don't want to be hitting buy on something that says £1,000 and they execute a trade that goes through at 1 million. So that's an extreme example, but obviously quality is really important. And I'm pretty sure that most people are writing tests around a lot of the stuff that they do. So the application needs to be highly testable. So I wrote this talk a while ago. So this is Nicholas Zakas, is that how you pronounce his name? He was principal engineer at Yahoo. This is from 2009. I'd highly recommend you watch this because it covers a lot of stuff that I talk about. It's really good. So, and there's obviously a very kind of modular front end similar to the Yahoo UIs that we saw earlier. So that's definitely a good reference point. So the solution, it's a very kind of woolly solution, and people have been talking about don't say modular anymore. But this is actually Brian Ford from Angular, who quoted Substack, who's James Halliday, saying, write small, focused modular parts and progressively combine them into bigger things to make your app. And that is the solution. That's what we've done at Kaplan. That's what Kaplan have done. That isn't anything new, I don't think. I think everyone here is going, I've heard that a million times, I've read it 100 times. It doesn't make any, it's not a big deal. But I want to kind of go into how Kaplan have done that specifically. So they build applications out of features or components. There's a services layer, which again isn't anything new. It's a software engineering principle that's been around for ages. There's a services idea in Angular. There's services idea in Ember. MV Star has been used a million times. But again, I want to explain which one Kaplan use and why. Testing should be efficient. So by efficient, I don't just mean fast, I mean reliable. You need to rely on those tests to give you decent feedback. And then there's tooling to support that workflow. So hopefully I can explain all that sort of stuff. So my diagrams are pretty terrible. This is a Google Draw diagram that I came up with. And then the Atomic CSS talk by Thierry, he mentioned ball of mud. So that's exactly what this is. This is an application which is just a ball of mud. It's all your application code and logic. So you've obviously got to split that up. We're trying to make things modular. So if we split it up into feature, this architecture diagram again looks like this. But if we want to look at something like Gmail and understand what that means, it could mean this. Obviously, I didn't work on the Gmail team, but this is what I might do. I'd break it into things like the search functionality, things like this set of tabs, a view of my emails, my labels. One of the things I really like, and I'll probably refer to it quite a bit, is this compose view, because it offers a lot of rich functionality, but it's clearly a component. It's clearly a feature within your app. So I want to talk about what problems that specifically solves. So the first one is something we probably won't like to hear, is that from a business point of view, it results in efficient use of developer resource. Now, I don't like to be called a resource, but if you split an application up into features and you can build features on their own, then it is efficient use of developers' time. If you twist that, you can say, well, it means I don't have to wait for other people to build other features. I can focus on getting on with this development that I want to do. This happens quite a bit, or happened quite a bit, because if you've got a large code base, you've got multiple people contributing to it, you get the latest from your source control, somebody's broken something somewhere. Now, it could be that I'm working on this feature at the bottom. Someone's checked in something which breaks this feature at the top. Why should that change mean that I can't do any more development? So we can obviously roll back. There are ways around this, but it is a problem that we come across. This is Gmail. So say I'm the developer working on Gmail. I'm working on this talk functionality. I've made a change. Now, even with live reload, say live reload kicks off the page refreshing. So when I jump from my editor back to Chrome or whatever browser I'm using, it's refreshed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, I do live in Scotland, and my broadband isn't particularly good. And I guess, there are faster ways of doing this. But if I'm running the full application, then that's 10 seconds between me making the code change and seeing that reflected in the UI. Now, I'm going to end up in TweetDeck. I'm going to end up reading my real email somewhere. I'm going to end up making a cup of tea. It breaks my developer workflow. So again, it's a simple problem, but it actually has impact. Another really simple problem. You've got a large code base. Where do you find your code? I've kind of hinted on that already. So I'll go straight into the solution for that one, and that kind of feeds into everything else. Things like Rails have generators that have an assets folder, and say underneath your assets folder, there's your JavaScript, and there's your CSS, and there's your HTML templates, and so on. The problem with that is it results in, you can create like a tree to try and identify where your features are, but you end up with this big pile of mess. So the solution that we've gone for is, we're building our features in isolation anyway, so why not have a feature name folder and then all our assets associated with that in the same folder? So images, HTML, config, JavaScript, tests, and so on. Who's doing that already? Only a few people then, okay. So because we know where everything is on disk and the tooling has this idea, right, we know that all the assets associated with that feature are on disk, we can take this FX trade tile excuse me, and we can run it in isolation. The tooling knows where all these assets are, understands how we build these things, and ignore these things for now, these panels. This is something we call a workbench, and where we've got our individual feature running in isolation. But how many times have you started creating a little feature in a little test page, and then eventually you've gone, I think that's right, I'm going to stick this in my app, and then your test page just gets lost. We've actually gone, well, the test page is a really good way of making sure you're building that feature in isolation. It doesn't rely on anything else. So we've made that a core part of the tooling that we do. And I think things like web components are going to make us think about this sort of thing, whether they're the right approach or not. So the nice thing about all of this is that we're not affected by changes elsewhere unless we're using shared code. Now, libraries and so on are still a problem. But if you have all your assets associated with that feature on disk together, it's clear that your team or you are editing that feature, the code related to that. So it's less likely that someone's going to make a breaking change on your code. It's easy to find those assets. You can obviously run that feature in isolation, and you get faster reload times because you're only loading the assets that are actually part of your component. A little note on just how we kind of bring things together. So we've got all these individual features. What do we do? So we create these things called blades. So it's called Blader in a JS, hence they're blades. But you can think about them as components. And we build a bunch of these features, and then we have something called aspects. They're basically entry points into your application, and it's just a way of saying, in this view, I'm going to use the rich email composer. I'm going to use the rich email list. I'm going to use the search feature, and so on. And maybe a compose view, and I've said that, labels and things like that. And then you go, right, that's that. There's some of this functionality that I want to use elsewhere. So it could be that you restrict things through login, so certain users get access to certain features. Or it could be that you go, well, the tablet doesn't really suit the rich compose feature because the way that it takes inputs doesn't quite work well with the pop-up thing on the tablet. So you might create a different feature for that specific tablet. So it's just a way of picking and choosing the components that you want for different views into your application. So the services, it's really, a really simple concept. Who uses services in their kind of JavaScript application architectures? So what, 8 maybe? 8 people. So again, it's been around for a while. It's just a software engineering concept. It works well specifically at scale. We found it works well. And we tend to use it for accessing shared resources. So if we find that 2 components want access to a similar thing, then we create a service out of it. One example is into component communication. Now, it could be an event hub, but an event hub can end up, again, a bit like a ball of mud. So you might create specific type services. So things that persist, that maybe persist to local storage or persist over the wire via a RESTful service or some sort of real-time service like Pusher. That's what services are. Again, I'm not going to go into that. I know some people probably don't like this idea of services. There's a really good talk by Mark Trostler from who worked at Google, and he wrote a book on testable JavaScript. And he talks about these services and that they are really contracts, protocols, or interfaces, and that's how Kaplan treat them. You're working against an API, you're not working against an implementation. So I certainly recommend watching this, and it explains a lot of the value to that. But it basically means you can change an implementation really easily without affecting the rest of your code. So we've now got this cross-cutting concern of services. And it's really used, again, because features can't communicate with each other. If they do through services. And if anything needs to access any kind of back-end, again, it does through the services. So if you think about when you start on an, say there's an application that already exists, and you're getting started, you might have a whole bunch of services that your app relies on. So you've got authentication to log in, databases, you've got real-time service, web APIs, and so on. And to get started, you need all of these things up and running. You need their specific runtimes, configuration, for all of those different things. And I think from experience, you might find that sometimes it can be a complete pain to get these things up and running. There are other problems, like if you're working with a third party, these services might actually not be available yet. One of the good things about this is that if you're building a feature in isolation, you actually only need the service running for the thing that you're building. So I only need my authentication service running if I'm building login. I only need my real-time service running if I'm building the real-time news. But even better than that, because we've got a JavaScript layer, JavaScript services layer, we don't need any backend services running at all. We can inject pretend, fake JavaScript implementations and just get going there and then. Now, sometimes you won't need to do that, but sometimes there will be value. You know, we've had times where customers will say, right, we can only deliver you that in 3 months. You have a conversation, what's the format of the data, how will we be interacting with that service, and you build a little kind of testable to help you work through that. This isn't a particularly difficult concept, and just to give an idea of how kind of we've done it, it's a lookup on a string. So it really isn't difficult. There's a point at which, like at Bootstrap, you say, right, I'm going to create an instance of something and I'm going to register it with the service registry, and then when I want to use it within my feature, I say service registry.getService and pass in the string. It's not tough. There are loads of different ways of doing it. There are some magical ways. There are not so magical ways and ways that people can understand to do it as well. We've actually changed it, because we use CommonJS, we've actually changed it so that we use require syntax now. We just have I think require.js might do this. You have an exclamation mark and then the service name. So a nice way of requiring these services. So they support this idea of the modular architecture. They make sure that features don't communicate directly. It's easy to change the implementation. So in different scenarios, you can obviously change the implementation, or as technology changes and you decide to move away from socket.io because it's not scaling for you, you can use your pusher implementation and so on. Or you can move back if you decide you want to own your own stack. But the really nice thing is that for different scenarios of work, you can inject the different types of services. So workbenches, test, and app. So in the workbench scenario, this is pretending to be a real-time stream of data, this component on the left, the prices panel. So it's registered itself with a service registry. It said, I provide real-time data. When the FX tile in the middle instantiates itself, it says, hey, I want real-time data. It gets access to that service. It doesn't know that it's actually just getting fake data from this little panel on the left. And what that means is that during the development process, I can just push through fake data and see how my feature reacts to certain states in my app. We've done the same thing on the right-hand side with something which represents the state of a trade, because it's kind of this weighing up of how often are we going to be doing this? Is it worth writing a little feature to help us build this functionality? But certainly in large apps that are going to be maintained for a long time, it's worth putting in this effort to help the development process. In tests, we can put in testables or mocks into the service layer and make sure that the interactions we're expecting are occurring against the services, or that your functionality is being worked as you expect when the services do certain things. And then in the application scenario, the real instances of these objects are instantiated and added to the service registry and used. So I want to talk a little bit about testing, and as I said, kind of testing drove a lot of this. Because we've got this services layer, we can create, use our testables in there. And the point really here was that when we're writing tests, we tend to try and avoid I/O, don't we? So we tend to kind of try to avoid things going over that network layer because we find it unreliable. It's outside of our control. So we can do that now with the services layer. We can avoid I/O. The other thing that we found was that we kind of treated the DOM as like a runtime boundary, because we would find that for various reasons the DOM was unreliable. It could be our fault. It could be that we would make HTML structure changes, or we would make class name changes, and we wouldn't think that that would affect our selenium tests, but it did. There are obviously nicer ways of managing this sort of stuff, say, for instance, data attributes that are specific to tests or identify components and so on. So we basically had this rule of don't touch that DOM. So our solution to that specifically was MVVM. So what we would have is a view model, which was a logical representation of the state of the view. And we chose to use Knockout. This was Knockout 1.0. And it was the only thing really available to us at the time. So for instance, if the view had an input, the view model would have input enabled, true or false. We'd let Knockout do its job and deal with that binding. So we'd run our tests against the view model. We'd have domain-specific functionality in a domain model, which now means that as things change, we can still use our application domain model logic, but we can change the thing that deals with our UI binding and rendering. So in future, we've done some spikes with React. We've got to reuse some of the domain model logic, but we can use React on the front end. And we haven't done this yet, but there's no reason why we can't use web components for that kind of front-end rendering technology. So the main thing here is that we're trying to support change. Now, there is a little bit of work that goes into this. Sometimes it's quite hard to find that functionality and push it down, but it certainly helps. You know, for Angular, we can do our tests against the scope. For React, we can do our tests against the virtual DOM. And obviously, those components that use knockout can do tests against the knockout model. The nice thing here as well is that we can actually build applications that use multiple front-end technologies. You're obviously adding a bit of bloat. Because there isn't an application-wide reliance on knockout, we can actually move some of the components over to React and so on. But the real win has been that because we've got a services layer and we've got a view model layer, we can put a testable in or mock at the services layer, interact with our view model, and see the interactions that occur against the services layer. We can get our testable service to behave in a particular way, and then check the state of the view model. So we can actually test our feature entirely in isolation with end-to-end functionality, obviously with the exception of the view. So around 4 years ago, we used to have this as kind of our testing triangle where we had a whole bunch of unit tests at a class level. We had application end-to-end, a whole lot of Selenium tests around this sort of thing, and then a set of manual tests. We did a manual process. With this move to blades or component-based functionality, we still had a whole lot of unit tests, but we had a lot more of these blade functional tests, and then some smoke tests where we do run the application, we do have the back-end services running, but that's just to make sure that when you do plug everything together, it does still work. The big win from this is that it used to take 8 hours to execute our suite of Selenium tests on our massive code base, and it was highly unreliable. We made this move to testing our components and features in isolation. We had the same level of coverage, in fact, probably better, and it now takes 30 minutes for that same suite of tests. But also, because we're building these features in isolation, you make a change and it shouldn't affect anyone else. So you can run all your tests on your component, check in, and let the continuous integration environment check integration. So it only takes, say, a minute. I spoke in more detail about this at Scotland JS last year, so if you're interested in some of the Selenium problems and some of the ways we used to do things and the way we do things now, then that's worth a look. Finally, the last few minutes, I just want to talk about the tooling and what the tooling does. And how it helps. So we've got a defined workflow. We need to do things in consistent ways because these apps are around for a long time. We want people to be able to change teams and so on. So let's use Yeoman. Yeoman generator. It's only a few people, but the idea is that you're creating a common way of building your app. So Blade Runner JS does that, but the point is, you know, it's quite nice to have that. All the teams can do that. You have the same kind of project structure across different projects. You create a skeleton for your application. You create a skeleton for your feature, you write some code, you see how that runs in its workbench, what does that component look like, you write some tests against it, you execute those tests, you eventually bring them together in the app, you iterate through that, and you check in. So that's kind of the standard developer workflow. You identify things to automate, so things like scaffolding, things like having a development server, but the point is to promote consistency so that people change project and can straight away write business functionality. Testing's built in, bundling's built in. Again, this is kind of this isn't client compliance like PCI compliance. This is more about embracing constraints and accepting, have I spelled that right? Yeah. Accepting that when you have large teams, well, you're a large company with multiple teams, that you need to do things in consistent ways. And these constraints need to be enforced somehow. But the tooling can actually help you with that. And a lot of people are using things like JS. A lot of people are using a bunch of tooling to make sure people do things in consistent ways and do things properly. And that's really important. And you know, we have Blade Runner JS for that. We build our apps in one way. Our customers build apps in the same way. If they outsource some of the development, they build apps in the same way as well. And if you add a level of intelligence to your tooling, you can really benefit from that. So some examples are, we write our code in a common JS style, and the tooling understands that, so it can build dependency graphs of our code. It can also work out that because components contain CSS, HTML templates, JavaScript, if we reference a JavaScript file, it will bundle the CSS, it will bundle the ITN config, and so on. So we get that natural intelligence from that. We can enforce some rules. So for instance, we're saying that one component can't access code in another blade. Now the tooling knows that. So if it sees a reference, it blows up. It says you can't do that. And this is all because we have some level of knowledge of how we run code, but also some level of runtime. So it understands this idea of this services layer, and it can manually build, it can automatically detect dependencies and inject the right service for the particular runtime. So make sure that in your test scenario, your test double is injected into that service layer. So if you have some knowledge of your application architecture and how things work in your tooling, it can help you with that development flow. Obviously, you need to be able to identify the points that change in your tooling as well as in your app architecture. So we need a form of plugin. So it could be that we use CommonJS now. It might be that we move to ES6 in the future, so we need to change the way that we bundle stuff. It might be that we want to use TypeScript, that Martin will speak about next. That actually suits us quite well because we're trying to do some typing and some of the stuff that we do. But we need that point of change. It might be that we change the test runner. We use JS test driver at the minute. So hopefully I've kind of proven the stuff I was speaking about, so I just wanted to kind of cover those and how they fit. So there's a large code base. The idea of components and services identify how we structure that. We support complex interactions through really services, but components don't reference anything else, and we know that all communication comes through services. We've got contributor harmony because we're building our components in isolation. We know where that code base is. We've got services, and we've got tooling that support generating that code in the same place. And we know services generally live in the libraries. We can support that evolution of feature technology through this idea of components. We can change the rendering technology you want to use. We can change the libraries that they use. And obviously services, we can change the implementation. And the tooling really supports that productive developer experience. The idea is that they get the tooling, they create an app, they create a feature, and as I said, whether they change projects, whether they're enhancing an existing app, they know where to find the code, they know how things are done. And quality really comes from basically everything. The application architecture and the things that you do need to be highly testable. So MVVM solves the DOM issue that we're talking about and kind of helps with the separation of rendering logic. Services, again, the separation of concerns between accessing, going over the network and so on, and communication between components. And the tooling supports all that and really promotes quality in a more indirect way than running the tests, although it does allow you to do the tests. So everything above really helps with the quality thing. So that's it. Hopefully that was interesting. I don't think I've got any time for questions, but hope that was good. Okay. Have we got time for questions?